Today we are finishing up our Chapter 2 notes. We are on page 9 of our Chapter 2 notes, Section 2.8, which is solving rational inequalities. So we already solved equations yesterday. Now we're going to take a look at solving rational inequalities, and there's several steps here. First, note values for when the fractions are undefined. These are going to be called critical values. We're going to solve the inequality as if it's an equation, and the solutions to the equation are also going to be known as critical values. Then on a number line, we mark all critical values. Test a number in each section. Choose test values from each number line section and plug it into the original inequality. It's important that we go back to the original inequality to test it. If it's true, you shade this interval. Shade the number line to reflect the intervals that satisfy the inequality. And we're going to state our answers three ways, as usual: graphic, interval notation, and symbolic. So number 1, we have the inequality x minus 4 divided by x plus 5 is less than 4. X cannot equal negative 5. We're solving this as an equation. X minus 4 over x plus 5 equals 4. I'll write that as 4 over 1. And we'll simply cross multiply. So 4x plus 20 equals x minus 4. Subtract x from both sides, and in the same step, I'll subtract 24. Or, excuse me, I'll subtract 20. And on the right-hand side, the result will be negative 24. Dividing each side by 3, x equals negative 8. All right, so negative 8 is also what we call a critical value. So we place negative 8 and our other critical value, negative 5, on the number line. And now we have to test each of the 3 sections. This is one section, and then between negative 8 and negative 5 is the second, and then greater than negative 5 is the third section. So we come up with test values, and I'm going to test a number less than negative 8. I'm going to choose negative 10. So I choose negative 10, and I'm plugging negative 10 back into the original inequality. Negative 10 minus 4 divided by negative 10 plus 5, is that less than 4? That's negative 14 for a numerator over negative 5. Yes, 14/5 is less than 4. So we would shade this section. It tests yes. Now a number between negative 8 and negative 5, I'll choose negative 6. Is negative 6, subtract 4, divided by negative 6 plus 5, is this less than 4? Negative 10 divided by negative 1 is 10. Is 10 less than 4? No. So this remains open. A number greater than negative 5, 0 is a nice number to choose. Is 0, subtract 4, divided by 0 plus 5, less than 4. It'll be negative 4 over 5 is less than 4. That's a yes. So we shade this section. So this is our graphic solution. Symbolically, these are all values that are less than negative 8 or greater than negative 5. And interval notation, negative infinity to negative 8, union with negative 5 to positive infinity. Number 2, our first critical value, x cannot equal 2. Next, we'll solve this as if it's an equation. So let me write this as an equation. Even if I write it as 0 over 1 and cross multiply, we get x squared minus 2x minus 15 equals 0. Solving this, we factor the factors of negative 15 that add to negative 2 are negative 5 and 3. So x minus 5 times x plus 3 equals 0. So x equals 5 and x equals negative 3. So our two solutions are also critical values. We place all three critical values, 5, negative 3, and 2, on our number line in the correct order. We'll circle each. Now we know x could not equal 2, so that remains open, but our original inequality was a greater than or equal to. So for our negative 3 value and our 5 value, we'll fill those circles in. So now we have 4 sections to test. All right, so I'll test negative 5. Now, an easy thing to do here is to use the calculator. All right, so it'd probably be handy if you have the calculator, which I'm going to stop and get out. All right, so we're testing is negative 5 squared minus 2 times negative 5 minus 15 divided by negative 5 minus 2, is that greater than or equal to 0? All right. Well, what we're going to do is we're going to store the fraction in the calculator. So I'm going to do alpha y equals and put in the fraction x squared minus 2x minus 15 over x minus 2. All right. I press enter. It gives me an answer. I'm not showing you that yet, but next thing you want is the value of negative 5. So I go to the calculator and we put in negative 5, store as x. Hit enter, and then do second enter 2 times to get the fraction back up on the screen, and then when I hit enter, it gives me the value of negative 20/7. So my left-hand side here is equivalent to negative 20/7. Is negative 20/7 greater than or equal to 0? No. So we know we're not shading that section. Next, a value between negative 3 and 2. I'll choose 0 as a test. All right. I still have my fraction on the calculator, so now I'll go and I'll key in 0, store as x, hit enter, and then second enter twice will bring up the fraction. Now I hit enter. Now 0 is stored in for x, so the calculator will compute this fraction with an x value of 0. And the answer is 15 halves. Is 15 halves greater than or equal to 0? Yes. So we shade between negative 3 and 2. And then choose a value between 2 and 5. I'll choose 3. I'm running out of room here, so I'm going to bring this down. I'm just choosing, I'll place it over. Here's 3. I'll go back to the calculator. 3, store as x, enter, second enter again, enter, negative 12 is that value. If you were to replace x with 3, you would get negative 12. Is that greater than or equal to 0? No. So this remains unshaded, and then I'll choose my last value. I'll choose 10. 10, store as x. Second enter, 65/8. Is 65/8 greater than or equal to 0? Yes. So this section is shaded. Okay, so now symbolically, we have two separate sections here. We have an and part, that x is greater than or equal to -3 and less than 2, or x is greater than or equal to 5. Interval notation, we have bracket -3, comma 2, parenthesis, union with bracket 5, infinity. Next, number 3. First note, when our fractions are undefined, x cannot equal 0. Now we don't have just two fractions, so we cannot simply cross multiply. All right. The least common denominator is 6x, so we're solving this as if it's an equation. I'm going to multiply every single term by 6x to clear the denominators. Here the 6's would divide out. I'd be left with x squared. Next, the 6x's divide out, -1. And lastly, the x and x divide out. 6 times 8 is 48. Subtract 48 from both sides. X squared minus 49 equals 0. This factors into x plus 7 times x minus 7. So x equals -7 and x equals 7. So we have our three critical values, -7, 0, and 7. So we now need our test points. I'll test -10. All right, I'm going to test -10, -5, 5, and 10. All right. By hand, oh, we could, but I'm going to use the calculator. I'm going to key in the left-hand side. So that's alpha y equals x over 6, or minus alpha y equals 1 over 6x. Okay, so -10. Store -10 into the calculator. -33 over 20. Is that greater than or equal to -8/10? No, it's not. -33/20 would be smaller than -8/10. Next, -5. -5 stores x. Second enter twice. Oh, it's not coming up with a fraction. There it is. Okay, -4/5. -4/5, is that greater than or equal to -8/5? Yes, it is. So we shade between -7 and 0. 5 stores x. Bring back my fraction. 4/5. Is 4/5 greater than or equal to 8/5? No, it's smaller. So that's section remains unshaded. And then 10 store for x. 33/20 is 33/20 greater than or equal to 8/10. Yes, it is. So this section is shaded. Okay, now it was a greater than or equal to, so out of my three circles, the -7 and +7 should be filled in. The 0 is not, because it definitely cannot be 0, because otherwise we would have some undefined fractions here. So this is our graphic solution. Symbolically, this is an and. This is -7 less than or equal to x less than 0, or x is greater than 7, greater than or equal to 7. And then interval notation, bracket -7, comma 0, parentheses, union with, bracket 7, infinity. So these require a bit of work with the test points in particular. All right, next, number 4. Treat it as an equation. And this is nice that it's just equal to 1. So we can write that as 1/1. So we have the proportion. We can simply cross multiply. Before I do that, d cannot equal -4. All right, cross multiplying, 3d plus 2 equals d plus 4. Nice linear equation. Subtract d from both sides, that's 2d. Subtract 2 from both sides in the same step, 2d equals 2. Divide by 2 and d equals 1. Nice, only two critical values, -4 and 1. Circle each. D cannot equal -4, so that's going to remain open. But 1 is going to be part of our solution, so we'll fill that in because of the equal to part here in the original inequality. Okay, now our test values. I'll test -5, 0, and 2. And again, I'm going to use the calculator, and you can certainly use the calculator in class tomorrow. So I key in the left-hand side, the fractional part, alpha y equals, to get the fraction bar, 3x plus 2, denominator x plus 2, press enter, and then don't look at that value, that's an old stored value. You can't see it on the screen anyway. So now I'll take -5 and store it for x. Bring up my fraction by hitting second enter twice, and that's 13/3. Is 13/3 greater than or equal to 1? Yes, it is. So we shade this section of our number line. When I put 0 in here, I think it'll just be easier to do this by hand. 3 times 0 is 0, plus 2 is 2. So that's 2/4. Is 2/4 greater than or equal to 1? 1/2 is not greater than or equal to 1. That's a no, so that remains unshaded. And it'll probably be just as easy to plug 2 in. 3 times 2 is 6, plus 2 is 8. 2 plus 4 is 6. 8, 6, is that greater than or equal to 1? Yes, it is. So this is shaded. So symbolically, we have x is less than -4, or x is greater than or equal to 1. Sorry about that. And interval notation, -∞, comma, -4, parentheses, union with, bracket 1, positive infinity. And we'll hold off on number 5, and we'll do number 5 in class tomorrow.